Well, as expected, the 1032 threads in the maple didn't make it through the 100 parts. So here we are with one of them stripped, and I need to put in an insert so I can finish these and finally get these done. And I figured, not a problem. I have some inserts, and so I went to the parts bin and looked like I had what I needed, but I had one size that was too big, and one size that was, of course, too small, and so I'll have to come up with a different solution. So let's take a minute and talk about these EZ-Knife brass inserts. They are made by EZ-LOK, and they are designed for use in hardwoods like oak, cherry, and maple. The inserts are ideal for use whenever assembly or disassembly could lead to thread erosion or stripping. The EZ-Knife thread inserts for hardwoods use a proprietary external knife thread that slices into the wood to provide superior holding power. They're often machined out of brass, but they are also available in stainless steel for additional corrosion resistance. The pull-out force for any insert is dependent upon the material that it's installed in, and these inserts are no exception. And you'll see here on the pull-out chart that even this little 1032 has a pull-out range from 500 to 1200 pounds. Of course, I do have a set of inserts that are intended for steel and aluminum with thread locker. These will work for wood, but I'll have to take the additional step of actually threading it to make it work. The inserts can be installed with a flat blade screwdriver, but I'd recommend spending the $10 to pick up the EZ-LOK driver if you're doing any quantity of these. It's very quick and foolproof. The inserts were then added to the 3D model of the fixture so that the paths could be programmed in CAM. The operation consists of three tools: a letter I drill, 0.272, a thread mill, 5/16 18 thread, and finally a CHAMFER to break the edge. Thread milling requires three axes to move simultaneously, normally X and Y in a circular motion, and Z axis will follow the pitch of the thread. This is normally referred to as helical interpolation, the machine's ability to move in a helical motion or in a helix. Thread mills are great for blind holes. They can also do inside and outside profiles with a single tool, both right hand and left hand. When setting up your thread milling operation, it's important to spend some time on the passes tab. Make sure that your thread is set for right or left hand, that your pitch is set correctly, and that you have your correct diameter offset. Additionally, you want to set your climber conventional milling. Typically on an ID hole, you'll climb out of the hole. That's how I remember it. Inch threads are typically called out as threads per inch. In this example, we have 6 threads per inch. To calculate the pitch of the thread, or the distance between the crests of the thread, take 1 inch, divide it by the number of threads, 6. This gives you the pitch of the thread, 0.1667 inches. It should be noted that metric threads are a lot easier because they're defined by their pitch. No calculation required. The machining is pretty straightforward. Start by drilling your 2 holes. Here it's a letter I. It's a 0.272 inch. It's running at 4,500 RPMs. Next comes the thread mill. It's also running at 4,500 RPM. It will start by dropping to the bottom of the hole and then slowly helix out at the feed rate. I'll try to zoom in a little bit closer so you can see the helical motion of the cutter. It's going in a circle and coming up at the same time. When I set up this job, I grabbed this CHAMFER tool from the library, and the coolant setting is actually in that definition. And I didn't turn on the coolant neglect and started flooding the machine. I'm installing the inserts using a battery-powered impact, and it's just important to just kind of come at it slow, make sure you're lined up nice and straight. The first insert went in really good. The second one, you can see I'm crazy crooked, and I tried straightening it out, but I don't know that I got it dead straight. So something to definitely watch for. With the inserts installed, it's just a matter of installing the next part and reassembling the fixture. And here you can see I'm just putting in the last screw. Now it's time to get back to work. About 60 or 70 more parts to go. Thanks for watching. Have a great day.